it's given that A cross B is 0 and B cross C is 0, then we have to prove that A cross C is also 0. So A cross B is 0, that means A is parallel to B, because then only the sine of the angle, which is 0 or 180 degree, and doesn't matter it is 0 or 180, the thing is A is parallel to B. So A cross B implies A is parallel to B. B cross C is equal to 0 implies B is parallel to C. So any two sides, any two lines which are parallel to a third line are also mutually parallel. So we can say that A is parallel to C. If A vector is this, B vector is this, then prove that A cross B is equal to minus B vector cross A vector. So you can just prove this with your simple matrix multiplication. So this is your A and B, and this is your minus B vector cross A vector. So be careful about how to be careful about signs in this case. So I cap times AYBZ minus AZBY minus J times AXBZ minus AZBX. So here I put the minus inside and did it the other way around. So you can take the minus out also. Similarly, when you will do for this, you will get this, and you will realize that this is just the negative of this, and this proves A cross B is equal to minus B vector cross A vector. This will also be equal to B vector cross of minus A vector, or minus on the whole thing of B cross A vector. Prove that for a triangle, sin alpha by A is equal to sin beta by B is equal to sin gamma by C, where the vectors A, B, C form sides of the triangle opposite to the angles alpha, beta and gamma respectively. So if this is ABC, then this is your alpha, opposite A, opposite B is beta, opposite C is gamma. So let's draw a perpendicular from here to here, and we can say that A sin gamma, component of A along this line is A sin gamma, is same as C sin alpha. So A sin gamma is same as C sin alpha. Okay. So this gives you A by sin alpha, A sin gamma is equal to C sin alpha, therefore A by sin alpha is equal to C by sin gamma. Draw another perpendicular from here to here, and again we can write that B sin gamma, which is this, is equal to C sin beta, C sin theta is equal to B sin gamma. So again we can write C upon sin gamma is equal to B upon sin beta. So from these two we can see C by sin gamma is common, so we can say A by sin alpha is equal to B by sin beta is equal to C by sin gamma. X and Y components of the vector are 4 and 6 meter respectively, and the XY components of A plus B are 10 and 9 meter respectively. Calculate the vectors B and B's X and Y components, its length, the angle it makes with the X axis. So there is a vector A vector which is given, whose X and Y components are 4 and 6. So we can write it as 4 I cap plus 6 j cap, and A plus B vectors components are 10 and 9, so that we can write as 10 I cap plus 9 j cap. So if you subtract these two, you will get B vector is equal to 6 I cap plus 3 j cap. So that is the first part. Calculate the vector and its X and Y components. Its length, under root of 6 square plus 3 square. The angle it makes with the X axis. So again we will do the dot product with I cap and divide by magnitude of B vector into magnitude of I cap. So magnitude of I cap is 1, magnitude of B vector is 3 root 5, and B dot I is 6I plus 3j dot I, which is 6. So this comes out to be cos inverse 2 by root 5. Also you can visually think of it like this. This is B, which is 6I cap plus 3j cap, So the component of B vector along x-axis is 6 and along y-axis it's 3. So if this angle is theta, which is making with the x-axis, then tan of theta is by upon bz. So by is 3 and bx is 6. So it will be 3 by 6 tan inverse 1 by 2. So both these angles are same, as you can see by forming a right angle triangle. If tan theta is 1 by 2, then this hypotenuse is root 5 and it gives your cos theta is 2 by root 5. So you can do it either way, you will get the same answer, even though this is cos inverse 2 by root 5 and this is tan inverse 1 by 2, but both are actually the same angles. The compass of an aeroplane indicates that it's heading due north and its speed indicator shows that it's moving relative to the air at a speed of 120 km per hour. So whenever we say something is moving relative to the air or relative to the water, what we mean is that is the velocity, for example V aeroplane. So we say V aeroplane with respect to air is something. So velocity of aeroplane minus velocity of air is what has been given, not the actual velocity of the airplane. So it is relative to the air. For example, if the air is blowing in north in 10 meter per second and you are also running with the same speed 10 meter per second in the north, then relative to air your speed is actually 0. So, but your actual speed is 10 meter per second. So, when we are saying about relative to the air, that is velocity of aeroplane with respect to air, and in relative motion we did that, we can mathematically write it as VA minus V aeroplane minus V air. So, that is the speed which is given, and if there is a wind blowing from west to east at a speed of 50 km per hour with respect to the earth, then find the velocity of the plane relative to the earth. Now the wind is blowing west to east, so let's draw that wind. This is west to east VW, and the that speed is 50 km per hour. The compass of the aeroplane indicates that it's heading north. That means its nose is headed towards north. So in this diagram you can see that if you have a compass inside this aeroplane, the compass will point that this is the north, and the aeroplane, inside the aeroplane, you will see that you will feel that it's going in the north. It's moving a little bit because of the wind, but with respect to wind it is moving north, and it is moving that with a speed of 120 km per hour. So velocity of plane with respect to wind is 120 in the north. Velocity of wind is 50 from west to east. So resultant velocity will be Vp here. As you can check, Vpw plus Vw is Vp. That is Vp minus Vw is Vpw. So that we have studied in our relative motion. So compass indicates that it is the nose of the plane or where the plane thinks it's going. So when you think you are going somewhere, that is relative to the surroundings. So what is the surrounding here? Air. So with respect to air, the plane is moving north. So in the first part, find the velocity of the plane related to the earth, that is Vp. So Vp is vector sum of Vpw and Vw, and both are at 90 degree to each other, so we can directly square their magnitudes and take a root of it. So this comes out to be 130 km per hour. In what direction should the pilot steer the plane through the air in order to travel due north? What will be then the velocity of the plane relative to the earth? So he needs to change his direction in a way that it actually travels north. So eventual velocity right now here, for example, is not north, but eventually if it wants to travel in the north, then it has to try going somewhere to the left. Only then the wind velocity will get added and eventual velocity will become something in the north direction. So it has to try traveling here. So its velocity relative to the wind should be here, and then adding to that there will be velocity of the wind. So eventually it will move like this. Even though its nose is pointed in this way, it's trying to go here with respect to the surroundings, it's going here, with respect to the winds it's going here, but eventually when the wind speed is being added to its velocity, then its eventual velocity is in north direction. So here again it is 120 which is fixed, and this is 50. So this is your final velocity of the plane, and again it is a 90-degree angle. So velocity of plane is under root of 120 square minus 50 square. And but we are not supposed to find the magnitude, we are just required to find the direction. So direction, this is theta. If it is making some theta angle with the north, then your sin theta will be 50 upon 120. So theta is sin inverse 5 by 12. Water in the river is flowing with velocity Vw from west to east. A man who can swim with velocity v in still water. So here also velocity v is in still water, that means it is velocity with respect to water. Is on the southern bank of the river and wants to cross the river. In what direction should he swim in order to cross the river? First in shortest time and by shortest path. So we are doing the vector sum, we have to do the vector sum of two vectors whose magnitude is constant, and in case of the river even the direction is constant. So this is the direction of the water, which is Vw, it is constant. Only variable here is in which direction he should try to swim, that is velocity v. So if he tries to go path, if he wants to cross the river in shortest time, then he should try to maximize his velocity in north direction, and it will be the, and it comes from the, its eventual velocity comes from the vector sum of this and this, his velocity with respect to water and velocity of water. And velocity of water is parallel to the vertical direction, so it does not contribute anything to its vertical direction. Only thing that contributes to the vertical direction is his own velocity with respect to the water. So he should try to aim to swim here in the north direction, only then the resultant will have the maximum vertical velocity, and only in that case he will swim across the river in shortest time possible. So in order to maximize the velocity in y direction, that is Vy, he has to aim to swim in this direction. So mathematically you can see it as this: velocity final is v, its direction can be anything, plus Vw I cap. Now in order to have maximize velocity in j direction, you can, this should be written as v j cap. So this is for the shortest time to cross the river. And in what time it will cross the river? If the width is w, then w upon v is the time it will take to cross the river. For shortest path, he should try and eventual velocity should be exactly in vertical direction. That means the resultant velocity should be in vertical direction. So if his v is here, which is with respect to the water, in addition to the velocity of the water itself, its eventual velocity will become vertical to the, perpendicular to the flow of water in this north direction. So in this case, Vx will be equal to 0. So we need to try to make Vx is equal to 0 in order for shortest path. In order to cross the river in shortest time, we need to maximize Vy. Here we need to minimize Vx, but it should be 0, it should not become negative, because then again it will not be the it will not be the shortest path. Even this path is longer, even this path is longer. So exactly when it is vertical, then the path is shortest. A man can swim with a speed of 4 km per hour in still water. So again, in still water, that means it's the velocity of swimmer with respect to water. How long does it take to cross a river 1 km wide if the river flows steadily at 3 km per hour, and it takes the strokes normal to the river current? That means the direction in which it's trying to go is perpendicular to the river direction. So just like in the case of aeroplane, we we saw that the nose of the airplane was actually aimed in a different direction than the actual velocity of the aeroplane, the eventual final velocity of the aeroplane. Here also he is trying to take strokes perpendicular to the river current, but obviously the velocity of water will be added to that velocity and he will drift a little bit. If it were still water and he is trying to swim vertically, he will just reach the opposite corner, but now he is aiming to reach the opposite corner by putting his strokes in the vertical direction, but along with the velocity of the water he will drift a little bit to the right. So in this diagram you can see this is the velocity of swimmer with respect to the water, because he is aiming to go here in this direction, he is putting his strokes in this direction, but the velocity of water is being added into his swimming speed, and this is your final velocity Vf. So the question here is how far down the river does he go, and when he reaches to the other bank, how long, first part is how long does it take to cross the river. So its vertical velocity is 4 km/h and the width is, let's say h, it is given as 1 km. So 1 divided by its velocity in the same direction will give you time. So it is h upon velocity of swimmer with respect to water. 1 km by 4 km/h, so it will be 1 by 4 hour, which is same as 15 minutes. How far down the river does he go when he reaches the other bank? So he was supposed to go here, but he will be landing somewhere along this side. How far it will go is its horizontal velocity component times time. So horizontal velocity is Vw, because this doesn't contribute anything to the horizontal velocity, and time we already found from here. So our answer will be Vw times time. So it comes out to be 3 km/h times 1 by 4 hour. So again, instead of 15 minutes, because we want the units to be cancelled, we will mention it in terms of hours. So it will be 1 by 4 hours, and calculating this you will get it as 750 meters. A boatman can row with a speed 10 km/h in still water. If the river flows steadily at 5 km/h, in which direction should the boatman row in order to reach a point on the other bank opposite to the point from where it started? The width of the river is 2 km. So we did this problem already before. He wants to reach just the opposite corner, so his final velocity should be vertical. So it will be the vector sum of its own velocity plus the velocity of water. So it is 10, this is 5, so it should be something like this. So vector sum of these two velocities will be perpendicular to the flow of water. So if this is theta, then the sin theta will be 5 upon 10. So theta is sin inverse 5 by 10, sin inverse half, which is 30 degree. This is an interesting problem. As a car just starts from rest in a certain direction, a truck moving with a uniform velocity overtakes the car. Their time velocity graphs are represented here. Calculate the difference between the distances travelled by the car and the truck in 15 seconds. Difference between the distances travelled. So in this, this is a VT curve, so area below the curve will give you distance. So in 15 seconds, how much the car travelled? It is the area of this triangle, which is half 15 into 45. And what is the distance travelled by the truck during the same amount of time? It is the area of this rectangle, which is 15 into 30. So the answer is dc minus dt, distance travelled by car minus distance travelled by truck, is equal to this minus this, equal to minus 112.5. So it's negative because car has actually travelled less than truck. Time when the car will catch the truck. So the time when the car will catch the truck, that means the distance travelled by both car and truck will be exactly the same. That time they will catch. That means area between the curve at that time should be same for car and truck. So for this rectangle and for this trapezium, the inside area should be the same at some time interval, at some time point t. So let's say that it is some time t at which this happens. So let's if and it is definitely more than the triangle here, because when the till the triangle was till the 15 seconds, the car was actually behind the truck by this many meters. So car has to travel some more distance in order to catch up. Only then the area will become same. So if it happens at time t, then we can say that dc is equal to dt at that time. So what is the distance traveled by car during that time? It is the area of this triangle plus area of that rectangle. So half 15 into 45 plus t minus 15 times height, which is 45. So this is the distance traveled by the car. For the truck, it is just t times 30. So this gives t as 22.5. So in 22.5 seconds, the car will catch up with the truck. Or you can do it in another way. Car is behind 112.5 meter. So in order to catch up with the truck, it has to travel relatively it has to travel 112.5 meters. So this is the relative distance between the two, and this is the relative speed between the two. So Vc minus Vt is relative speed. Vc minus Vt is the relative velocity. So relative distance upon relative velocity will give you a time to catch up. Relative speed is here 45 minus 30, which is 15. So this will be 112.5 divided by 15, comes out to be 7.5. So this time it takes after 15 seconds. So our final answer is 15 plus 7.5, which is 22.5. Distance of car and truck from the starting point at that time. So it's just a question of for the truck it's just Vt, which gives you 675 meter, and similarly for car also you can calculate that this triangle area plus the area of the rectangle. From the graph you can find that out. A car is moving at 10 meter per second on a straight road, is ahead of another car moving in the same direction. So this car is ahead and it's moving at more velocity. Find the velocity of A related to B and vice versa. So velocity of A related to B is Va minus Vb. So here let's consider this direction from left to right as positive. So Va minus Vb will be 10 minus 6, which is 4, and Vba will be Vb minus Va, which is 6 minus 10, which is minus 4 meter per second. So the Vab and Vba, you can see that they are same in magnitude but opposite in direction. Two parallel rail lines are north-south. A train A runs north with a speed of 54 km per hour. You can convert that into meter per second, it will be 15 meter per second. And another train B runs south with a speed of 90 km per hour. Find velocity of B relative to A. So this B is going south at 90 km per hour, which is 25 meter per second, and A is going north at 15 meter per second. So whenever we are being asked to find the relative velocity, we should take one direction as positive, we should assume that, and then do the calculations accordingly. So let's consider this direction towards north is positive. So find the velocity of B relative to A. So it will be velocity of B minus velocity of A. So velocity of B is minus 25 minus velocity of A. So minus 25 minus 15 comes out to be minus 40. The velocity of ground relative to B. So velocity of ground relative to B, that is velocity of ground minus velocity of B. So minus of velocity of B will be plus 25. So with respect to ground it is 25 meter per second north. Velocity of a monkey running on the roof of A against its motion. So A is moving this way, so this is the train A. So A is moving up with 15 meter per second, and the monkey on the top of it is running against, that means trying to run to the south against its motion with velocity of 18 km per hour, which is 5 meter per second. So it's running 5 meter per second with respect to the roof related to A, as observed by a man standing. So the velocity of the monkey. So we need to find the velocity of monkey as observed by the man standing on the ground. That is the actual velocity of the monkey. So velocity of monkey with respect to train is velocity of monkey minus velocity of train. So from there we can say the velocity of monkey is just replace that. So velocity of monkey with respect to the train, it is due south, and south is negative from our convention, so it is minus 5 is equal to Vm minus, what is Va? Va is positive and it is 15 meter per second. So this gives Vm is equal to 10 meter per second, and it's positive, so it is north. So this makes sense also. The monkey is on the train, and the whole train is moving at a very high velocity. So even if the monkey is trying to run on the other side with respect to ground, the monkey is still going to the north. A jet airplane traveling at a speed of 500 km per hour ejects its products of combustion at a speed of 1500 km per hour relative to the plane. Find the speed of the latter with respect to an observer. So simple question of relative velocity again. The velocity of combustion with respect to plane is 1500, and this is the velocity of plane, which is 500. So considering this direction is positive, this is the velocity of plane, this is the velocity of combustion with respect to plane. So V of comb with respect to plane is equal to V of comb minus V of plane. So if this is positive, this direction is positive, 1500 is negative, and this is V comb minus this is 500. So this gives V comb is equal to minus 1000 km per hour. So it's negative, so velocity of comb is 1000 from in the left side. So opposite to the opposite to the direction of actual plane. On a long horizontal moving belt, a child runs to and fro with a speed 9 km per hour with respect to the belt between his father and mother located 50 meter apart on the moving belt. So all three of them are on the belt which is moving. The belt moves with a speed of 4 km per hour. For an observer on a stationary platform outside, what is the speed of the child running in the direction of motion of the belt? These are the two parents, and the belt itself is moving at 4 to the right. So let's consider this direction as positive. The child is running to and fro. So when he is running in this direction, let's say it is so this what I have indicated here is velocity of child with respect to belt, because that's what is been given to us, which is 9 km per hour. And while returning also, it will be velocity of child with respect to belt, which is still 9. Now for the first part, velocity of child with respect to belt is Vc minus Vb. So velocity of child is Vb plus Vcb, and in our problem it is given Vb is 4 and velocity of child with respect to belt is 9. So when it's running along the belt, as is been asked in the first part, then it is 4 plus 9 is equal to 13. The speed of the child running opposite to the direction of the motion of the belt. So opposite is this case. So when it is moving in this direction, then it is again here Vb plus Vcb, but here in this case the direction Vcb is from right to left, and it is negative from the assumption which we have taken. So this will become 4 minus 9 is equal to minus 5. So in this case, first case, it was along the direction of the belt and it's positive by our convention, so both of them were positive. Here Vb is still positive, but velocity of child is now negative, so it is 4 minus 9 is equal to minus 5. So we can imagine that if the child was running with 4 km per hour in the opposite direction, for the observer it will look like he is on the same spot, because he is trying to move 4 km per hour on the left and belt itself is moving 4 km per hour to the right. In that case it will become 4 minus 4 is equal to 0. But here the child is faster, so eventually even though the belt is moving to the right, for the observer the child is running to the left. Just opposite to the case of the monkey, where the monkey also was, eventual velocity of the monkey was also in the direction of the train. Here the belt is quite slow, so the eventual velocity of the child is actually the opposite of the direction of the belt. Time taken by child in A and B. So he is running between the parents. So what is the time taken to travel that distance between the parents? So when it is with respect to parent, again we can write the time as the displacement upon velocity of child with respect to parent, and this displacement is also the with respect to the parent only. So this displacement is not with respect to the observer on the ground. So with respect to parents, with respect to this parent example, for example, when he is running from here to here, so with respect to this parent, the distance travelled is 50 meters, and the velocity of child with respect to belt is 9. So our time will be displacement upon the velocity of child with respect to parent, or velocity of child with respect to belt. Both are same because parents themselves are on the belt. So this becomes 50 by 9 km per hour. Which of the answers alter if motion is viewed by one of the parents? So first, A and B will obviously vary, because for the parent the velocity of child will always look like he is always running at 9 km per hour, whereas for the observer on the ground it was different depending on which side he was running on. But yeah, for time is same, it doesn't matter who is observing it. The time it takes for the kid to go from here to here is independent of where the observer is sitting. So any observer will see that he went from here to here in same amount of time. We'll do more problems next class.